Alright, if you're going to retake this Unit 2 test, here's the second assignment we're working on. It's out of 2.3. Number 16, you see it right here, cosecant squared of x minus 2 equals 0. Your job is to solve it. So hit pause right now and let's see how far you can get. Alright, welcome back. So, first thing I have to do is get the cosecant squared by itself. So I get equals 2. Then I'm going to need to take the square root of both sides, which is going to leave me with the cosecant of x equals plus and minus the square root of 2. So I hate the cosecant, so I'll use the sine. So the sine of x equals plus and minus 1 over the square root of 2, which after I rationalize that denominator, I get plus or minus the square root of 2 over 2. So if I go to my unit circle, and that's plus or minus the square root of 2 over 2, so I know that's going to be at all my 45-degree angles. So I get pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Great. We only got a couple more to do here. Good job with your first one. Alright, your second problem is number 38 out of 2.3. 2 sine squared of x plus 3 sine of x plus 1. So hit pause. Solve the problem. And when you come back, I recommend using master product here. A times c is step 1. Step 2 is the factor. And then step 3 is to come back and divide by a. That is an a right there at the top. Alright, so we'll do a times c. Sine squared of x plus 3 sine of x plus 2 equals 0. So again, it has to multiply to give you 2 and add to give you 3, which is 2 and 1. Sine of x plus 1 and sine of x plus 2 equals 0. Now remember, we do have to come back and divide by the a that we multiplied the first time. So I end up with sine of x plus 1 half equals 0, and sine of x plus 1 equals 0. So sine of x equals negative 1 half, and sine of x equals negative 1. Again, if we go to our unit circle, negative 1 is really easy. I get 3 pi over 2. And for the sine to be negative 1 half, I cannot use the top two quadrants. Sine's the short side. So it looks like I'm going to use 7 pi over 6 and 11 pi over 6. You would definitely, on your retake, have to factor a quadratic. So be ready for that. Alright, 36. We're kind of working our way backwards, but now here's the first multiple angle problem we'll have. Because I have a 4x right there, I know I'm going to get lots more angles. Actually, I'm going to get 4 times as many angles. So we can jump into this. Instead of secant, let's change that to cosine. If I take the reciprocal of the secant, I do have to take the reciprocal of the other side. So when is cosine positive and when is it a half? So it looks like we'll be right there and there. So I will say 4x equals pi over 3 plus 2 pi n, and it looks like I have 4x equals 5 pi over 3 plus 2 pi n. In order to solve for this, I have to multiply by 1/4. Remember, you have to distribute that to each of these pieces. So I get x is pi over 12 plus 2 pi n over 4. In order to get a common denominator there, I'm going to multiply top and bottom by 3. So I get pi over 12 plus 6 pi n over 12. Sweet. So now I can start getting my solutions. The first one, of course, is going to be pi over 12, and I'm adding 6 every time. 7 pi over 12, 13 pi over 12, and 19 pi over 12. Have to stop there because if I went any further, I would get past our 2 pi. Now when I come over to the other one, again, I have to do the same thing, multiplying by our 1/4. So once I distribute that to every piece, I'm going to get x equals 5 pi over 12, and because I already know the common denominator, that is not going to change. So I can go right ahead and say plus 6 pi n over 12. So my solutions here are going to be 5 pi over 12, 11 pi over 12, 17 pi over 12, and 23 pi over 12. So instead of the 2 solutions we expected, we got 8 because of that original 4x at the beginning. Alright, here's the last problem out of 2.3. I think this problem was tough on the test. Oh yeah, hit pause. Solve it. Set it equal to 0 first. So, like I said, we're going to subtract cosine of x. Remember, if you don't know what to do, set it equal to 0. So, I get cosine cubed of x minus cosine of x equals 0. And now I can do a greatest common factor. So I can factor out a cosine of x. That leaves me with cosine squared of x minus 1 equals 0. And now I can ZPP. So cosine of x equals 0. Cosine squared of x minus 1 equals 0. So it looks like I'm going to have to add 1 on both sides here. Then take the square root. So I get cosine of x equals plus and minus 1. So if you take a look, cosine is going to equal 0 at pi over 2, 3 pi over 2. And cosine is going to equal plus or minus 1 at pi and at 0. So that gives me all 4 answers. Remember, the key to this problem was setting it equal to 0 to start.